Oh no, you'll need more than that. Okay, so today we're going to talk about constructing points of concurrency, and you're going to do that using patty paper. And so if you look at this, we've got two definitions that I need you to get down in your definition list. The first one is concurrent lines, and those are lines with a point in common.
Where's my pencil? Gosh.
Concurrent lines are lines with a point in common. Then we have our point of concurrency, which is actually the point of intersection.
Are these?
Okay, and so those are two definitions that you need to understand. So first of all, again, concurrent lines are lines with a point in common. They don't have to be parallel because they can't be parallel. Just any lines with a point in common. And then we have our point of concurrency, which is actually where do they intersect, at what specific point. And so today you're going to be completing some constructions. And you're going to use those, or use patty paper to complete those. So now what we're going to do is we're going to go ahead and look at this on page 178. So on page 178, your first step is to draw a large triangle on patty paper. Okay, so draw a large triangle on patty paper.
That they draw one or?
I got it. Draw a large triangle on patty paper.
I got
Make it
you.
up.
Your second task then, once you draw that large triangle, is you need to construct the three angle bisectors for the triangle. Construct the three angle bisectors for the triangle. Now, before you do that, let's review how you can do an angle bisector. If you've got your triangle here, how you can create the angle bisector is just fold the angle in half so that they line up. Yep. And so go ahead and construct those. When you get that constructed, I want you to go ahead and complete the conjecture. We're going to go over it in class, and then we're going to do another construction.
We have to write down the conjecture.
Yes.
Was it supposed to be an equilateral triangle?
Nope.
That's covered.
What are we doing? How do you do that? Oh, I see.
Okay, so do you have your conjecture filled in?
No. What are we supposed to
The three angle bisectors of a triangle, what do?
Intersect.
They intersect. Okay, so they intersect. So they meet at a specific point, and we call that specific point the in-center. So if you're writing this down you could write a definition down and say in center, the point of concurrency of the three angle bisectors of a triangle. Okay? So the in center is the point of concurrency for the three angle bisectors. Now if I were you, you've got your patty paper there, I would maybe write on there in center where the point of intersection is. Now, you've got another sheet of patty paper. Yeah, you can write on that one. You've got another sheet of patty paper. What I need you to do is set that second sheet of patty paper on top of the first, and I want you to trace that exact same triangle, and I want you to complete the same investigation, except for this time you are doing the three perpendicular bisectors. Okay, the three perpendicular bisectors.
You can use a ruler.
Now, if you want to, go ahead and take your third sheet of patty paper and trace the triangle if you wanted to do that and get it done. But now remember to do a perpendicular bisector. What you're going to do is fold that on itself.
So we fold them just like so.
So yeah, so basically this is what you're gonna do. You're gonna fold this one over, fold this right there. So that segment onto that segment. So did you go ahead and construct your perpendicular bisectors?
There's three
You have
of
to
them,
do your
right?
three perpendicular bisectors of each of the sides. So to do your perpendicular bisector, you're gonna do this. Okay, that side, that one, goes over that one, and then increase, and we'll do that with all the other three sides. Okay, so the first one was your in center.
What if our angles are not the same? Does that matter?
What do you mean?
The angles aren't the same.
What
That
angle?
is
They won't be.
Okay.
You're doing the perpendicular bisector, that just bisects this side.
That's what it's supposed to look like.
So, is that right?
Yeah, that's right.
Even if it doesn't go.
Oh, yeah, that's fine. Yeah,
Okay.
because remember, that's a perpendicular bisector, so if
That's
you look at it,
line.
that's a 90-degree angle,
Okay.
right? And it bisects the side, so maybe
Yeah, perpendicular.
this side and that side.
That's parallel. Just checking your, yeah, sure you are. Thanks.
So we've got another conjecture that you should be coming up with. A perpendicular bisector concurrency conjecture. What happens with the three perpendicular bisectors of a triangle? What do they do?
Meet at the same point.
They meet at a point as well. Okay, are concurrent. We have a special name for that. This ones are called the circumcenter. Okay, so you could, if you were writing this conjecture in your notes, you could put the three perpendicular bisectors of a triangle are concurrent, and then you could put they meet at the circumcenter, something to that effect. You could even label your patty paper circumcenter for that one.
It's rated pretty good,
It's rated pretty good.
which is good. So it's really dry. Well, these are dry for fuels plus you don't want it to be too dry. Well, I know, but still, if you get too
Okay,
dry,
so let's go ahead and look at our next investigation. Our next investigation is found on page 178. Say you should have a triangle there. The three altitudes. So now you need to construct the three altitudes.
I got this.
Are we supposed to copy the
I got
triangle
this one.
lesson too?
What?
I do it. What? That is.
You can do it.
I bet you it
Do
is.
that.
Skip over it.
I can't.
I don't care. Do
Parallel
whatever you
line.
like.
Takes too much time. And then I
No, it
don't
don't.
get to write things down.
You
So
don't
if you're
have-
struggling with this, you can go to page 170. Actually, this one's page 180. you could go to page 180.
No, I got time, you can do it. Yeah, I'm right.
I take that back, it's on page 178.
I'm right. You know, if you do it that way, you're gonna do what we just did last time.
We're doing altitude. Altitude is straight up and down from that.
Yep.
thing.
What's altitude?
The altitude is the perpendicular from that point, from the vertex to the other side.
So it's the same thing as last time?
No, it's not the
Straight
same thing.
down from this line.
It's different, okay? So what you're gonna do is
Angle, exactly. You did it wrong.
fold it over. And you've got to make a 90-degree angle.
That's what we did on this?
Huh?
That's what we did on this?
No, that's the bisector. See, the altitude means it goes from this side here down to this side. So what you're gonna do is line those two up, you see that? Let's see what it goes to this side right there. You're gonna do that one on the other side. So did we get our 3? How are you guys doing with your altitudes?
Good.
So what can you imagine is gonna happen?
They're all in.
They're gonna intersect at what?
The middle.
At the middle. Now we have a special name for this one.
That's good.
These are called the orthocenter. So now I want you to think.
What if they don't intersect at the middle?
They will. If you've done it right, they should. Not at the middle, at a point.
Makes it a triangle in the middle.
No, we weren't. You were.
You thought it was something else.
Probably going. How fast?
Probably not very. It's just wax.
Okay, so now I've got a question there at the bottom. I want you to think about, for what type of triangle would all 3 of these be the same?
Probably equal, equal triangle, or what's called, but equilateral triangle.
An equilateral triangle, good. So an equilateral triangle allows all the points of concurrency to be the same point, okay? So that would be equilateral. Okay, so now let's go ahead and look at our next slide. The circumcenter. So now this is investigation 2. This is on page 179. Using your patty paper from steps 3 and 4, measure and compare the distances from the circumcenter to each of the 3 vertices. So if you remember, the circumcenter was what? Which one was the circumcenter?
Is that the first one we did? No, second one.
The perpendicular bisectors. So find the perpendicular bisector sheet you have. Okay, the perpendicular bisector one. That's what kind of probably would
Is
have.
that the first one?
That's the
Oh,
second one we did.
the second one you did.
This one.
So what you need to do now is you need to measure from the circumcenter to each of the vertices.
It's 3. I'm starting on 1.
Now meanwhile, while one person is measuring, I need you to grab a compass.
2 or 1?
Just one. What do you notice about all of the measures?
They're all the same.
They're all the same. So the circumcenter of a triangle is,
The same.
is equidistant from the vertices. The circumcenter of a triangle is equidistant from the vertices. Now what I want you to do, okay, I want you to take your compass. Now this is step 2 on that investigation at the bottom of page 179.
We're still on the same.
You're still on the second page. It's our second patty paper. Take your compass. I want you to put your compass where the circumcenter is. I want you to open your compass to the one of the vertices. Doesn't matter which one. Okay, now what I want you to do is hold that down and try and draw a circle. See what you notice.
Oh, they're gonna be the same.
Nice.
It makes a perfect circle.
Ah, it makes a what?
A perfect circle.
A perfect circle. Now, yeah, yours guys might have come off the side. This is what the board just came out to be. Kind of like a yours.
I didn't-
And so if you notice, the circumcenter is exactly in the center
Of a circle.
of and that's called a circumscribed circle, because we've used the circumcenter to draw that. Alrighty, let's look at another.
Oh, that's amazing.
Okay, using the patty paper from the first 2 steps of investigation 1. So this is with your angle bisector 1. Okay. Measure and compare the distances from the in-center to each of the 3 sides. Measure your in-center. So this was the very first patty paper you should have.
3 sides of the
Measure it to each of the 3 sides.
So that's 1 and.
On the same, on the perpendicular.
No, you're doing this one only on your first one. So all you do is take your ruler, measure from the in-center.
It's gonna be the same.
So basically what you're going to do is measure along that
Oh, okay.
segment.
Is equidistant from.
So what'd you notice, girls?
4 inches.
It's the same. It's equidistant from the sides.
Oh, no, there, I get now.
So I can gestures.
Okay. Alrighty, so what you need to do now, okay, so you have your assignment. And here's your following assignment. You need to complete 1 through 6 on pages 181 through 182. Now, let's go ahead and look at number 6. You want to keep your patty paper with you. Okay, so number 6. Number 6 says, draw a large triangle, construct a circle inscribed in the triangle.
Something's inside the triangle.
Inside the triangle. Yep. So do you have the in-center right there? Because we've already done number 7. So go to that patty paper.
No, I think I know how to do it.
What do you do?
Oh, okay, I was gonna say this. You take that one, this one,
Yep.
you do the same thing, only you measure from,
The side.
Right.
you put it in the center and you put it from there.
So go to the one we just got done doing, the first one you did with the in-center. Place your compass where the in-center is. Open your compass up to the distance between that and one of the sides. Go ahead and draw your circle, and that is how you create an inscribed circle.
one.
So there you go. That number 6 is going to be a joint answer from you and your partner. Now you need to do 1 through 5.
Okay, so we